Hello, today I will be showing you how to find and draw the maximum, minimum, and average lines of best fit in a graph. So suppose we have this graph here. We have the x-axis, y-axis, and we have our points with uncertainties and error bars. So in order to find the average line of best fit, which is most likely what you will be looking for, we need to first find the maximum and minimum lines of best fit. So in order to find the maximum line of best fit, we want to find the line of best fit which has the greatest slope. So to find this, we want to take our first point, which is going to be this one here at 1, 1. And we're going to look at the error bars here. And we want to basically find the smallest point possible, if that makes sense. And so this will usually be found by the bottom left corner of the error bars. So you can basically picture that these error bars form like a square around this point, and we want to take the bottom left corner of this square. And so this is where we're going to start our maximum line of best fit. And we're going to end it at our final point in the top right corner. So this is our final point, and we can picture this box again, the square. And we're going to end it at this final top right corner. And once we have those 2 points, we can simply just connect them with a ruler, and we can draw our maximum line of best fit. So now that we have found our maximum line of best fit, we need to find our minimum line of best fit. So this can be done through a very similar process, except now we want to find the line of best fit with the smallest slope possible. So once again, we're going to picture the square around our point that the error bars form. And instead of starting at the bottom left corner, we want to start at the top left corner. So this point here. And instead of ending it at the top right corner, we want to end it at the bottom right corner. So here. So let's go ahead and draw this line. So now we have roughly our max and min lines of best fit. Obviously, there's going to be some human error if you're going to be drawing this by hand, but most of the time for questions, this is going to be negligible. Now that we have these 2 lines, we have to find the slopes. So we can do this simply through this equation here, where the slope can be found by y2 minus y1 over x2 minus x1. So we're going to need 2 points on each line. Let's start off with our max line of best fit, and we can go and find 2 points. So looking at our max line of best fit, we can see that approximately there is 1 point over here at 5 and 3, and it looks like there's another one here at roughly 7 and 4. So now we take our y2, which would be 4, minus our y1, which we found was here at 5 and 3, and then over our x2, which we found was 7, and our x1, which we found was 5. So now we just calculate what this is, and we get a slope of 1 over 2. And now we repeat this process for the minimum line of best fit. We find 2 points. Looks like 5 and 3 once again works. And we find a second point. Looks like here at roughly 7 and 3.5. So now we just do this. And we get 0.5 over 2 or 1 over 4 as our min line of best fit. Now, in order to find the average slope, we can simply average out these 2 values. So we take our max slope, we add it to our min slope, and we divide that result by 2. So I'm going to do this on a calculator. So let's say we have 0.5 plus 0.25, and we just divide that by 2, and we get a slope of 0.375. So now that we have found these two values, we can go and find our y-intercept, which is the final piece that we're missing. However, in order to find the y-intercept, we need the y-intercepts of the max and min lines of best fit. So once again, we can go back to the lines that we drew, and we can see that we didn't actually connect these to the y-intercept. But we can simply extend these lines to make it so that they do touch the y-intercept. So it looks like our minimum line of best fit touches the y-intercept at roughly 1.4, and our max touches the y-axis at roughly 0.25. So 1.4 and 0.25, and we just simply average that. So once again, we can put this on the calculator. And we get an average of 0.825. And now we have every piece needed to construct the equation for our average line of best fit. So we can simply write the equation here. Y is equal to, and then the average slope that we found being 0.375, x plus our y-intercept of 0.825. And so now we have found the equation for our average line of best fit. However, we still need to graph it. Graphing it is actually very simple. We simply take the y-intercept that we found, and that will be our first point. So 0.825 is roughly around here, this point here. And in order to find a second point to connect it to, we can simply just plug in a value. So we can see that our max and min lines of best fit end at somewhere around 9.5, and so we can just plug in 9.5 into our average line of best fit equation, and we get a value of 4.3875. So we go to 9.5 and 4.3875, and we can finally connect these 2 points. And that will be our average line of best fit. It's quite difficult to see in this example, but hopefully this still helped.